Hello, I think we're live here. I had a hard time with getting it started, but this is Darren DeNeve once again, and we are making math team videos, practice videos as we have been doing. We'll start with a little math tidbit. So you might notice here that 10 squared is 100, and 11 squared is 121, and 12 squared is 144, and 13 squared is 169. What's sort of interesting, I guess, we could write 1 squared if we wanted to as 001. 11 squared is still 121, but 21 squared, see, I'm reversing the digits, and it's true that 21 squared is 441, and 31 squared is 961. And so that's sort of fun. And so you might think, well, what about 14 squared? Well, 14 squared is 196, and so, 41 squared, it's like, whoops, it's not 691, but it is. If you kind of look at the pattern here, the 1 stays the same in the 1's digit. The 10's digit went from 0 to 2 to 4 to 6, and it would be 8. And then in the 100's digit, 0, 1, 4, 9, they're going up by squares, and so this is 1681. 15 squared, okay, we might have to think, okay, what really happened here? Well, 1681, that's actually, 196, you could argue, is a 1 in the 100 spot, and an 8 in the 10 spot, and a 16 in the 1. So 100, 8 10s, and 16 1s. Okay, and so when we reverse that, you can see what's 1681. And so if you look here, on the 1's digit was 0, 1, 4, 9, and then 16. Okay, we're going to call this 25 to begin with. And then 0, 2, 4, 6, 8. So this would be 10. And then this is 1. Okay, and so 51 squared would be 25 hundreds. 10 tens, and 1 1. Well, 10 tens, yeah, is 100, and so this is now 26 hundreds. So if you looked at 51 squared, it's 2601. I think I could have done this a little better, but a 14 squared is 1, 8, and then 16. So 16 ones, 8 tens, and 100. Okay, all right. That's sort of fun. Okay. So here we go. Let's see what happens. We're on question 5 here on the Algebra 1 test. And so it says that we're going to determine the value of C when we do this polynomial work. And so you can see that you're trying to multiply a couple of binomials together, and then you got this thing going. Anyway, the answer is it just wants the x term, and so if it just wants the x term, then that's what we shall give them. And so here, x times 3x is 3x squared, so that's no good. But we have x times negative 2, so we have negative 2x, and then we have 4 times 3x, so that's 12x. And then here, this would be 4x cubed. That's not what we're after. 4x times negative 3x yields an x squared, but 4x times 7 is 28x. 2x squared is not what we're after, but we are after 2x. We're not after negative 2. And so this is relatively fast. You multiply, or not multiply, but you add all these up and you get 40x. And so the answer is 40. All right. Let's get to the geometry one. Again, the idea here is that you really ought to maybe pause the video and try it yourself. Okay. And so here's number 5. It says that the measure of angle DBA is 17.13, and the angle DCA is 11.87. And we want to find CDB, okay? And so you might recall that CDB, okay? So you could think like this: 17.13 And the angle that I'm pointing at here have to add up to 180, whereas then the three angles in the triangle have to add up to 180, and so therefore 17.13 has to be the same as 11.87 plus the angle we're interested in. We'll just call it x. Okay, it's called the exterior angle theorem. Again, just so you remember, like this one and this one have to add up to 180, and then this one have to add up to 180, and so therefore the sum of these two must be the same as this one. And so it's a simple subtraction problem, as it turns out, and you get 5.26. Let's look at the Algebra 2 one. In Algebra 2, question 5, it says the first term of an infinite geometric series of non-zero terms is 4/3 the sum of all terms in the series. Determine the common ratio of the series. Well, you might recall that a infinite geometric series, or how about just a geometric series, is one where the consecutive terms are found by multiplying by a common ratio. And so an infinite geometric series that we can find the sum of has to have a common ratio of less than 1. And so as an example of one that's sort of easy to figure out, I guess, is if we took 1 and then half and then a fourth and then an eighth and then etc., okay, sooner or later you'd get really, really, really close enough to 2 where you would just say this is 2. And so the formula, if you've done some of this in class, is that you take the first term and you divide by 1 minus the ratio. And there's a really cool algebraic reason for this. I suppose I could do it in a different video maybe. But the first term is 1, the common ratio is a half, and you'll notice that that's 2. And so now back to the original problem here. The first term, so we'll call that A, is 4/3 the sum of all of the terms. And so we just told you that the sum of all the terms is A over 1 minus R. And then it says, what is R? Okay, and so if you do a little math here, multiply the 1 minus R over, perhaps, and divide by A, you'll notice that you have 1 minus R is 4/3. And so therefore R is negative 1/3. R is negative 1/3. Okay. Moving on to the pre-calculus. In pre-calculus, question 5, it says that the coordinates of the point that is the center of the conic section given is the ordered pair. Determine the ordered pair. So we're supposed to find the center of that conic section. For what it's worth, that conic section is a hyperbola because it's x squared minus y squared. It has an x squared term and an y squared term, and the signs are different. Copied it down wrong there, didn't I? You might recall that the one way to find the center here is to put things in standard form, which includes completing the square. And so x squared minus 2x plus some number, and then minus y squared plus 4y, be careful with your negative signs, plus some number equals, and those would be 4 plus a number plus a number. Now, this is a contest, and so we want to be as fast as possible. This would be x minus 1 squared minus y plus 2 squared equals something. Okay, remember it's half of 2 goes here in the 1 spot, and then 1 squared is there. Half of 4, and then there. Anyway, so the center, without even going any further, because that's what the question asks, is 1, negative 2. If you did want to get this, do better job with the whole format, okay, you would put a 1 here and a negative 4 here, okay? Because this is negative 4. You do the same thing with both sides. This works out to be 1. And so this is a pretty simple hyperbola, actually. But the center is at 1, negative 2. All right. That's it for today's video. Hope you enjoyed.